Section 1.5 is applications of linear equations and modeling. So there aren't any really new formulas for this section, but what we are going to do in this section is now essentially do word problems, right? We want to use lines to model real-world scenarios. So the first problem says we have the value of a newly purchased boat is a linear function of time. So that means the equation can be modeled by a line. The boat was purchased for $15,000. If the value of the boat decreases to 75% of its purchase price in 3 years, determine the value of the boat after 7 years. So the first thing we're going to have to do here is model this scenario. So when they told me, right, the purchase price, that would be at time 0. So when the boat was brand new. So we'll say at time 0, the boat was worth $15,000. Then we were told that 3 years later, the boat had decreased to 75% of its purchase price. So because it says decreased to 75%, that means the value is 0.75, right, times the original 15,000. If I had said it decreased by 75%, then that means I would have multiplied this by 0.25, because that means I would have removed 75% of the value. So if we decrease to 75%, it means it's lost 25% of its value. So you always multiply when you're doing percentages by the percentage you still have. So you always want to make sure if you're giving anything in a percentage form, is that the percentage we took away, or is that the percentage that's still left? So for example, when you go shopping, right? All companies, they're going to advertise about the money you're saving. So if there's a 10% off sale, you're paying 90% of the original price. So you should multiply every price you see by 0.9 to get what you're going to pay. If you multiply by 0.1, you're just seeing the money you're not paying, right? So if we actually calculate this out, our second point is saying that the boat is now worth $11,250. So now what I have are 2 data points for the value of this boat. So from this, I can calculate the slope and write the equation of the line. So I'm going to take the change in y values, 11,250 minus 15,000, divided by 3 minus 0. So once again, notice how my y and x value here come from the same point, and my x and y value here come from the same point. So the numerator, when we divide this out, we get negative $1,250 per year. So it should make sense that you have a negative slope because this boat is decreasing in value, right? And the units on top were dollars, the time on the bottom was years. So now if I write the equation of the line, I can pick either of these 2 points. And unlike the previous problem we did where the points were just numbers, right? It doesn't really matter. You're still going to get the same line no matter which point you pick. But if one of your points has a 0 in it or a 1, you should probably pick that because they're much easier to deal with when you're working with them. So I'm going to pick the first point, and it's y minus 15,000 equals negative 1250 times t minus 0. So the only reason that I renamed xt in this problem was it was time, right? But you could technically call it anything you want because they didn't specify what the names of the variables needed to be. So if I want to multiply this out, it's actually quite easy. The right side is just going to be negative 1250t. So y equals negative 1250t plus 15,000. So I have the model, right? But we want to make sure that we read the question properly. And what the thing actually said was to determine the value of the boat after 7 years. So I need to know, what is this boat worth in year 7? So we do that by plugging 7 years into our equation. And we see the boat is now down to $6,250 in value. right? Example 6 is a great problem that I like because sometimes on exams, we like to give you conceptual questions. And it's very intimidating for math students when we ask you a question that doesn't have any calculations involved, right? So when we ask you something like this that's very open-ended, just, write it in your own words. We're not expecting any formal math speak. We really just want to know what's your logic, make your case. And this particular question I've used on my own exams before, and I've actually gotten multiple correct answers because people interpreted the problem a little bit differently, but if they made their case, and some people drew me pictures to prove their point, I was able to give full credit for actually different responses. So this question says, Kim really loves donuts. She's also concerned about her health, so she wants to track how many calories a week she consumes due to her donut habit. If she lets X be the number of donuts she eats in a week, Y be the number of calories consumed per week from donuts, and assuming a linear relationship between X and Y, answer the following. So the first question is, should the slope of the line be positive, negative, or zero? And then this is the part that people freak out about, right? Why do you think so? So let's deal with the first part, the slope. So we know that slope is the change in Y over the change in X. So Y was defined to be the number of calories assumed per donuts, and X was determined to be the number of donuts that she eats per week. So it makes logical sense, right, that as X increases, right, she eats more donuts, then Y increases. And Y was calories from donuts. So notice here we said we're not measuring the calories of everything else she eats, we're only measuring the calories from donuts. So the more donuts you eat, the more calories you're consuming for donuts. So if we kind of think about this in terms of this fraction here, well, Y is increasing as X is increasing, so that would be a positive, right, over a positive, which would give you a positive slope. Conversely, if she eats fewer donuts, right, X would be decreasing, but then her calorie intake would also decrease. And that would give you a negative over a negative, which would also come out to be a positive slope. So the slope is positive here. Now I had one very clever correct answer on this question where someone gave me a negative slope. And they actually drew a picture, and this was really kind of cool. They noticed here I said calories in a week, but then I put she was concerned about her health. So they actually plotted a graph where they would make each data point her weekly consumption and argued the point that as she saw the first or second week how many calories and donuts she was eating, that over time she would reduce her intake, and actually showed that the way they measured the linear model that you could have had a negative slope here. So it was a very clever argument to make, but positive is sort of the most obvious answer due to this particular setup of this problem. The next question said, well, should the y-intercept be positive, negative, or zero? So what we're really asking when we ask about the y-intercept in a real world scenario type question is what we're actually asking is, what does x equal 0 mean, right? So in some scenarios, 0 might not make any sense, right? So if we gave you a line that measured the blood alcohol level of someone, right, and that line happened to have a negative intercept, well, if you plug 0 into the line and got a negative BAC, right, you can't have negative blood alcohol level, right? There's either alcohol in your blood or there's not, right? The same thing would be if we were measuring for a drug in your system or something like that. So for some quantities, if you have a negative B, right, on the problem, like 0 doesn't always make sense, right? So the y-intercept is where the graph crosses the y-axis, and that is at x equals 0. But in this particular problem, it's pretty obvious. If she eats 0 donuts, then she consumes no calories. From donuts, okay? So if we kind of actually drew that out, right, we would see that as the number of donuts increase, the number of calories increase, right? So the intercept should be 0.